as a dev, we are doing great work. We are writing great algorithms. We are writing great APIs. But as soon as we as soon as we are ready with the feature, we want it to be into production as soon as possible, right? Because we have hard deadlines on our head. We want our code to be in the hands of user as soon as possible. When we reach our the ops guy to release our APK to the Play Store, we encounter several problems. Like because we during the tenure of creating the APKs, we created so many of them because one we have last moment bug fixes. Some of the APK is not looking good on some of the devices, and so on. The ops guy will have this problem of finding the right APK. Then he has his own checklist to publish the APK into the Play Store. He has to check whether the build version is right or not, build number is right or not, if whether the APK is signed properly with the right key store, whether it is right, pointing to the right environment, and so on. If any of these checks fail, the ops guy has to come back to the developer to make the fixes, and then this to and fro between the dev and ops can lead to so much energy loss. This can lead to this. So we need to maintain a balance between devs and ops. We have different nature of work, right? So as developer, we work in the environment of agility. We follow agile development, right? So we have to like with the demand and the solution. With time, the demand and solutions they keep on evolving. We have to maintain our pace with that, right? So as soon as we get a new feature to work on, we start work on it, and code cannot be perfect in the first go, right? We have to iterate over it over and over again, and ship a code to the production environment. And on the other hand, ops are someone who wants the availability and the stability. They do not like the change very much because if we make a minute change to the APK, this is going to make their life hard because they have to perform so many checks. The checks that I really recently told you, whether the APK is right or not and pointing to the right environment. So if anything fails, he has to again come back to the developer. How we can bring a balance to their life? We can have CI/CD like continuous integration and continuous development that can bring a balance to their life. By definition, continuous integration is integrating small pieces of code, like committing small pieces of code into the main production branch. When you are merging, an automated suite will verify whether your changes are correct or not. If they are not, you will be notified then and there, and you will not merge a bad code into the production. CD is about the continuous delivering the integrated code. The code can have a bug fix or a feature. So CD will ensure that the code which is there in the main branch will be delivered to the user in just one click. What it does for us, it keeps things simple. Reduce the risk of release failure. Our primary objective is to reduce the risk of failures. We develop beautiful apps. We put so much hard work into it. And if we develop an app, we launch it into the Play Store, it goes into hands of the user and it crashes. You are going to face so many hate comments from the users. Your users will bash your company on Twitter, and most importantly, your business will lose money. No user is going to come back to an app which crashes. So, how do we escape from this disaster? What we can do is the best known technique is make small and incremental changes and test every change with whenever you push some change to the production, test it. So while as a developer, when we are actually creating a pull request, we should focus on creating a pull request in such a manner that we should think over it, that the smallest valuable step I can make towards this feature. What is that? And once we scope our pull request, then it should be something it is release ready. We can directly push that into the main production branch and release it. We should not wait for long feature branches to cut and then goes into the production. long chunks of code can bring error to the system, but the small pieces of code are cleaner and easier to read, and then it will prevent anything bad from happening, right? Um, in these two diagrams, in two charts, these are the long features branches that we're taking. The long chunk of code is going, and that is the small incremental changes that we are pushing into the production. Time taken by in both the process are nearly the same, but that one is a lot safer. What this brings us? It brings us faster time to market. Small patches of code is faster to put into the market. Reviewer will review the code faster. Your code will be tested faster, and it will ship to the market faster, right? So the quality of the code maintains. Fewer lines of code is something which is understandable. If you have reviewer, if you have a peer that looks into your code, the bugs and the error that you may introduce into your PR will be caught easily in the small chunks, and you can maintain the quality that way. Integration. Your code also impacts someone else's code, right? Big chunks of code can break things anywhere, and you won't know it. Automated. When you automate your code and your test cases, and you have test cases around it, you will have more faith in your development. If a functionality is broken, your test will notify you then and there that something is broken. So automation tests are very much important in our life. Whenever the PR gets merged, it's release ready. An ops guy can directly take your PR, can take the latest build from that particular branch and release it to the market. Devs are happy, ops are happy, everyone is happy. Automate all the things that are possible. So we must focus on producing reproducible build. It is very easy to say that something does like something works on my machine. If a tester comes and says show you something, but you have a very good escape, it works on my machine. But you're not working for your machine. You're working for everyone else. There are millions of devices out there with various screen sizes, densities, resolutions, and you have to produce your APK for all of them. So how can we achieve that? You can have different kinds of automated suites and that run your code on different emulators. Now you should test your application. This thing cannot be stressed further. Test everything you write. Bugs hide in tangles of many code changes. If you have written a piece of code 6 months back, there might be a chances that someone else has overwritten over it and might break your functionality, your existing functionality. If you have your test cases around it, you will know that if something breaks, you will be notified about it. If you accidentally break one of others' feature, then also you will get notified about it. Your testing infrastructure should be solid, and your developers must feel that the infrastructure we have is solid. They will, if we have such a confidence in our testing environment, then we will be very confident. We will feel more comfortable shipping our code changes directly to the production. Automate your delivery process. We have a different environment for different type of APKs. Dev environment for the developers, QA environment for the testers, pre-prod environment for beta users, and the prod environment which is for your final users. And if you're in a company like Expedia, where you have so many white labeled apps, and assume creating so many apps for these environments with so many different white labeled apps. You have to take care of so many things. So with different applications, you have different application IDs, you have different build versions, you have different key stores, and if you're doing everything manually, it will be a troublesome for you. How do we perform continuous integration? When a developer commits some changes, it pushes its codes to the source code. The developer pushes the source code to the SCM, and we have a static code analysis tool, which can tell you if there is any error in your code. Like it can tell you the lint errors, it can tell you the style check errors, it can tell you whether your functions are efficient or not. It can tell you whether there is a potential null pointer exception in your code. Once you push your code, then you raise a pull request. When your pull request is raised, you perform a set of multiple tests on it. We run unit test cases. Unit test cases are the one which cover the block of code. Automation test, we can have libraries like Espresso, which will test your app from end to end, and so many other test cases. If any of the tests fails, the report will be sent directly to the developer. Developer will fix it, and then the cycle can go on. Principles of continuous delivery. Principle 1, every build is a potential release. Commit only deliverable code to the production. No dummy data, no oops. Every release should be able to go to the market. Second, automate wherever possible. Imagine doing all of the things by yourself. When you write a code, you run your test suite on it, unit test cases, then you wait for some time, then you run a regression suite on it, then you wait for some time, if everything is happy, if you have green tick on all the levels, then you push your code to the product, to the SCM. But it is going to take a lot of time for a developer's life. It is to be done after every commit, right? So if these things can be automated, try to do it. And eliminate manual bottlenecks. The process, in our process, we have lots of manual blockers like manual QA, manual deployment. If there is a way to eliminate those, try to do that. Fourth is have automated tests that you can trust. Invest time in writing good tests. Don't write tests for increasing the coverage. Write because you want to trust them. If some functionality breaks, you need to know it. So you must be able to trust your test in such a manner that if nothing is breaking, your code is ready to go. How does continuous pipeline look like? We have an issue. By issue, we mean any code change that you want to push into the production, be it a bug fix, a refactoring, a feature, anything. This issue goes into SCM. SCM is the source code management system. For us, it is Git. For you, it can be SVN, Mercurial, anything like that. Any fancy SCM you have. Since our code is there in the SCM, we have already covered the continuous integration part. Now we are left with the delivery. We can have a script written with us that can generate your APK using the right configuration, increasing the build number automatically, picking the right version from the right files, targeting the right Android devices, choosing the right environments, and signing it with the right key stores. Yes. Now we have, with just one click, we have this APK with us, which is a release ready APK. Our ops guy can take this APK from here and release it to the store. Now Sarthak will tell us what are the different CI/CD tools available in the market to build our own pipeline.
Thank you, Shivani. That was a great explanation that why we should CI/CD and what's. So this is not just for companies. This is just even for the people who are freelancers, because you don't want your machine to be occupied for 2 hours just for no cause. If you want to have a coffee, you can take like a break, but don't make your machine busy. But there's a catch, and there's always a catch. What are the common pitfalls associated with CI/CD? If you don't have a CI/CD, and because we are engineers and we love to work on new technologies, we get all excited, we go hands-on to the technology. There are some things that you should take care. If you don't have and these common pitfalls come when you don't have a CI/CD pipeline. Like when you're starting to build, you are in the early phase of it. Automating the wrong processes first. You like to automate things, and you have hundreds of processes that you can automate. Which one are you going to pick the first one? Is it the one which tells that how much time was your pull request raised for? What time does it take to go into master branch? That's not the first process to automate. The first process to automate should be running unit tests on every branch. That's how you do it. Don't automate the wrong process first. Confusing continuous deployment for continuous delivery. Deployment means that every APK is being uploaded to a place where you can see, install on your app, and can work. Continuous delivery means that that app goes to the user. If you build 10 commits to your master branch, that doesn't mean that you have to push your APKs 10 times a day to your users. The user is just going to get confused. So there's a difference. Continuous deployments means that every APK is release ready, but it doesn't mean that you should release it. The third one is lack of meaningful dashboards and metrics. What are the metrics that you want to see? You cannot measure human happiness. What you can measure is how many commits does every PR comes with? How many times does your unit test fail? How many times does your lint fails? How can you improve that? Have valuable metrics. Lack of coordination between continuous integration and continuous delivery. So when we say CI/CD, these are two different parts, but they needs to be integrated with each other. That means what you can do is you build a commit, you review it, and it gets merged, but you're not generating APKs out of it. This is lack. So don't do that. Have continuous integration and continuous delivery work with each other. And the last one is maintaining a balance between continuous integration and continuous delivery. See, when you have unit tests, when you want to build things, these are going to run on servers and not on your machines. And you will pay for it. And if it's like I've seen a lot of people out here from startups, even for companies like us, we don't have money lying around. So you need to find the optimum balance, like for the jobs that run on your, like, how many times do you want to build an APK in the day? 4 times a day. How many times do you want to run an automation test on your master branch? 4, 5 times, 1 time a day. That depends on the use case by use case. But you need to strike the correct balance between them. Let's get started. So these are some of the common things that we go around. So single person is responsible for building, deploying apps, like single person, single point of failure. And a lot of other things that you say, and sometimes you just get so frustrated that you just want to die and you don't want to be on this planet. And this is like a reality that we face every day. So if you want to deploy something on App Store, what are the build steps? You set a version, you build your APK, you archive it, you submit it, you wait for it, and it gets submitted to the App Store. If you have to upload it on the Google Play Store, we have the same set of steps with difference here and there, but the things remain same. We can have a pipeline in place using Fastlane. So the question comes up is, what is Fastlane? Fastlane is a tool built on Ruby language. It's 100% open source that can help you make your workflows using code. And the last time I checked on Fastlane's website, they claim that they have saved more than 20 million plus hours of developers worldwide. That's a pretty huge number. Think about it. What are the Android tools? So Fastlane is just not for Android. It comes both for iOS and Android. What are the tools that it provides for Android? The first one is the supply. It's a command line tool for updating Android apps and the metadata on the Google Play Store. It's an automated tool. You can just tell it when it to run. You can have a cron job that will do it for you, update the metadata, and will submit it to the Play Store directly. No human involved. The second one is the screen grab. So many of the companies in India are coming with localized languages. Not all apps are in English. Some apps are in Hindi. For Expedia, the languages are Spanish, Italian, and many other languages that we need to support. And then we have to upload them. We have to upload them in the localized strings. And that can happen with screen grab. It's a single command that will run your app, take the screenshots of the app, and upload it to Play Store with the specific languages. It's These tools are free. They are completely 100% open source. If you don't have a functionality that you would like to for yourself, you can just commit and it will be available to everyone. That's the goodness of being open source technologies. It can connect to all build tools together. Gradle, whatever iOS uses. Define multiple lanes for different needs. We don't need a single lane. Like we just don't want to release the app. We want to run automation tests. We want to run unit tests and all the tests that Shivani talked about here. Continuous integration support. We will see there are a lot of tools that we can go with, and Fastlane works with 99% of them. You can make your own build steps. It's easy. It's a Ruby is a programming language. and you can just go and start using it. And Ruby is a scripting language and pretty easy to learn. So that's not bad at all. That solves a lot of problems. How can we achieve it? It goes with a single command. Open your terminal, go to your project root directory, just write Fastlane in it, and everything will get done for you. You don't have to worry about it. It will create some files in your system. These are not all the files that it will generate. These are some files where you have really mature Fastlane scripts, but these are some of the files that Fastlane inside Fastlane folders will live. That image is just so that you don't sleep. Okay, so this is 3 lanes that are automated already for you. But the people who are backward, who are not able to see it clearly, can look at the back TV also. So the first line that we say is that the default platform that we are using is Android. The first is that we want to run all the tests that says lane, test, we need to do Gradle. So Gradle is already a wrapper. You don't have to always write Gradle, W and everything for you. You just mention Gradle and what is the name of the task. Then we want to build an app and upload it to the Crashlytics folder. And that you can do is clean, assemble, release, and Crashlytics. So these are lanes. You can call lanes within lanes. It's like a programming language. Your lanes are your functions which you can call from anywhere. And things like Gradle, these are actions. In Fastlane, we call them actions. To do an action, so every lane has a set of actions and few other lanes if you want to use it. Then you have something like before. Before all means that, let's say that you have a use case where you want to build an APK. Whenever some code gets pushed into the master, you want to have that APK in your any chat app that you use within your company. For us, it is Slack. So you want to do that. How can you do that? Take the URL of the Slack, build your APK, push it to the Slack. So everybody in the company, every developer, every tester, everyone has the latest APK within seconds of getting built with everyone. And that's how you should do it. So that was Fastlane that can run on any CI/CD tool. But there are few CI/CD tools that are so awesome that you don't have to write that complicated code. And you can do it very easily. So first one is Travis CI. It's one of the most popular one out in the market. Then the next one is Circle CI. The good thing about Circle CI is that you can, if something is going wrong and you are not seeing it in the logs, for example, your operating system is not providing you something that you want, you can do a SSH on the box, see the logs and come back and rectify it. This is the most common one. It's a free, open source, deploy it on your laptop, deploy it on your boxes. It has a lot of community support. It doesn't have a very good UI. TeamCity, it is provided by the famous JetBrains. So you know that it has some out-of-the-box functionalities that you will like. And the GitLab. This is the one that we will demo today to you. We will tell you how you can push the code, upload it, build pipelines around it. GitLab is a single solution, has like most comprehensive solution for you. You can manage your dashboards. You can plan, like if you have Trello, Jira, or whatever management tools you use, you can have it within GitLab. You can have your source code management with Git inside GitLab. You can run tests, you can package APKs and do whatever you want within a single system, not leaving the complete environment. We have talked a lot. Let's see a sample pipeline. And this is the pipeline that is very easy and can work with even with small startups. So user writes a patch, it awaits lint. Linting happens and check style happens. And it can go back and forth. If your lint fails, it will await lint. If it passes, if the lint passes, it will start awaiting review. It is ready for review. And it will get 2 types of reviews. One is a human review. It can say, I'm fine with it. It can say, I'm not fine with it. And your unit tests run on it. If human review is fine, if your unit tests have passed, you are awaiting submission. Now your your patch is ready to be merged into the master branch, and now your patch is merged. As soon as your patch is merged, you can run regression tests. For the people who are old enough who don't know what regression is just checking that your functionality works. That old functionality has not broken, and you want to keep it intact. Because we all know my code will change something on somebody else's app. You have smoke tests. If it has web components within your APK, you will have Selenium tests, and then you will have test farms to run your tests. If everything goes fine, your patch is validated, your APK should be generated, and everybody should have it. This is all talk. Oh, sorry, I missed a step. Sometimes you can have some rules that if your change is so small, you can directly merge it to your Git master branch, and you don't have to wait for it to like awaiting submission and doing things like. If your unit tests have passed, merge them. A lot of talk, no demo. My friend Kapil will tell you demo and will keep you away from next 2 minutes.
Hi everyone, my name is Kapil. Thank you Shivani and Sarthak for taking us through this detailed feedback of CI/CD and letting us know about the tools which are at our disposal for integrating CI/CD into our projects. So today I hope that my demo goes well and I don't turn out like a Tesla truck. So I'll be using GitLab for this demo. So the first step which we need to do is to sign up, to go to GitLab and sign up over there. So I've already done the sign up, so I won't be doing that step over here. And the second thing which we need to make sure is that you add your SHA key to your GitLab account. We usually forget those things and we keep getting errors when we try to build them. So let's head over to the demo part. So this is my GitLab account. So first thing I will need to do is I will be creating a new project. So for this particular demo, I'm using Android Sunflower app, which I think all of you are quite familiar with. So let's just name it as Sunflower demo. I'll keep the repository as private as of now. So now my project is successfully created. I'll just add a readme file over here and an empty readme file. I'll create an empty commit. So what I have done is now is that I've created an empty sunflower underscore demo project over here at GitLabs. So the next step what I will do is I will push the Android sunflowers code to this repository of mine. Okay. So let's just open a terminal as of now. Let's clear it up. Check the status. Okay, so Git is not initialized as of yet. We'll initialize the Git. Okay, so Git is now over here. So next thing we need to do is that we need to add the origin and upstream things over here. So I'll just copy the URL first. Let's see if it's there or not. Yep, it's been successfully added. Now we'll just take a pull from this repository, empty repository. I think it won't work as of now. Yep. So it's saying it has unrelated history, so it's like readme.md. So we also have a readme.md locally and we have created one above. So we'll just first create a commit for this so there aren't any conflicts over here. Let's just add create a commit for this. Okay, we have created one. Let's just take full now. I don't. It's it's not working again. It's saying they have unmerged related histories. So we have got a command for that purpose as well. We can allow related histories. So we have taken a successfully a pull. Now let's just add all of our files and create a commit for those. Let's do GST. Yep. All of them are added. All the greater level file source, file strings. So everything is over here. We'll just create a commit for our. Let's just call this sunflower app. Now I'll just push it. Let's go over there. Yeah, that's been successfully pushed. So I hope the code will be here. Yeah, I think it's here. So all the circles are passed, app files, getting nodes, license getting everything is here. So far what we have done is that we have taken empty repository at the GitLab, we have taken our source code and just push it over here. Next comes our pipeline. Now we want to do actual stuff, actually build our this app of ours, actually create an APK from it, run unit tests over it. So we'll head over to the pipeline tab to see if our pipeline exists as of now. As of now, there is no pipeline. So what GitLab requires to create a pipeline is a GitLab CI YAML file. So this is what comes at the root of our project. This is a file which we need to create at root of our project. If you push that file to a GitHub repository, it will automatically start building. So that is a file where we specify all the commands, all the branches which we need, we are going to build. So I'll just create a root file in my root directory. Just add this one. Push it. I believe as soon as we get to push it, our build will start over here, and at first it should fail. Let's see. Yeah. See, as soon as I push this GitLab CI file, it tried to build it, but it's saying this YAML file is invalid. Why is it saying that? Because right now it's empty. There isn't anything in it which is going to read and help us build our project. So first of all, let us learn more about this GitLab CI file. What is it about? What all the commands or syntax does it have? So what is exactly GitLab CI YAML file? So this is where you configure what CI does with your project. So when I push this file, GitLab runner will run at the GitLab and will check all the commands which are there in this file and it will run those commands. And so this is a place where when you push your first commit or your subsequent commits to your GitLab repository, it will decide if it's going to run a job or not. Also, since GitLab, this file is version controlled, all of your branches will work completely fine. You won't have any conflicts like that, any build failures. If your separate branches are, all of them will work independently fine. So we'll now just look at the contents which come in this file. So just think of an empty GitLab CI YAML file as a new laptop which you get, where you want to install Android Studio and you want to build your APKs or source code. So the first thing which we usually do is that install JDKs. JDK 8 is what we usually do. Okay. We install Android SDK tool versions. We set our environment variables. We install platform tools, Android SDK for compile target. We do all of these things. All these 4 things I think you are already aware of. For running our build on the GitLab, what we need to do is we would need an executable GitLab to run our builds, because using that we are going to specify all the commands which we want to run. Okay. So now we'll talk about the things which are needed inside this file apart from these JDK repository tools. Let's talk about jobs. What is a jobs? A job is something which will define what is going to run for us, what is going to run at the GitLab. So this is mainly the syntax. This is build release is our name, and this asterisk build I'll talk later about this. Using the only you specify the branch which you want to run at GitLab CI. Using the script you specify the command which you want to run. And now comes second thing, stages. So basically you can define about different stages at GitLab CI. So what are those? You could have a build stage, you could have a test stage, you could have packaging stages. So stages is just categorization of jobs, is nothing else. You would have just different name of jobs. That's just the stages. And I also shown you an example of a test job over here. This is again a name of test unit. We have got the script, the command which we want to run at the GitLab CI. So this was all a kind of brief introductory about what will be the content of it. Now we'll just start adding the actual content over there and we'll try to build our own project. Let's go back and this is the project. I've already loaded this project, so I don't need to talk for now. As of now, you can see that this is an empty file, right? So the first thing we'll be doing is that we will add our JDK. We'll do all of those things which are required to install SDK tools as of now. So first thing, let's add some commands for installing JDK. Right. So this is the command which will download our JDK, Android SDK, sorry, Java JDK for us. Now we can declare some variables, our app name and the Android SDK tools which we want to. If you guys can't see, please let me know. Is it visible now? Is it visible at the back? So let's declare some variables of our app name and our SDK tools version. Okay, so I declared some variables, app name, sunflower. This is all the syntax of that. Next, we'll create a before script for downloading all these things. So this is my before script. So what is happening in this before script? As you can see, the first step is doing that I'm fetching the Android SDK tools over here from Linux or Dash. You have to specify the URLs over here. Let me just get this. So first thing is then I fetch those SDK tools, then I unzip them. Next step, what we usually do is that we export our environment variables. I'm setting Android home path. Then, as you know, that whenever we're installing SDK tools, we have to accept all those licenses which come. But since we want any UI over there, we would have to do this dynamically. So we'll create a licenses directory over here, as you can see. And in the next step, yes, Android home, I'm going to that part and accepting all those licenses. And then I'm creating an executable grid review for us. So in this before script, as just the name specifies, it's going to download everything which is needed to run an Android project for us. Now that we have got everything to run, we'll write our jobs, which are going to actually build our project for us. Okay. Let's just specify some stages. Again, I will be using 3 stages. We will be writing 3 jobs for us, for one for build, one for test, and one for packaging. So first, let us write build job. Right. So this is the first one, build template. What is a build template? So basically, a build template is just like a template function of you, which you are going to reuse within your jobs. So you can So whatever commands which you will write over here, you can reuse those commands inside another job. So stage is basically what stage is this function going to run. I've specified the stage as build, so this will be the first one. It will run in the build stage. Artifact is basically output of your build. It could be your APK, it could be a PDF file which you generate, it could be any other Word document which you want. So I've specified that artifact will expire in 4 hours after generating. And where would I pick up that artifact from? So I've specified the directory that app build outputs will be the directory where the artifact will be located. So this is the template I have created for build. Now I'll specify the actual build jobs, just like which I talked to you about. So this build template def is going to fetch all these commands and basically bring into this one. So right now what we have done is that we have fetched all those 4 commands. We bring into this, and we have specified some extra things. We specified the branch we want to build, and what will be the command which we want to generate. So this is just gradle assemble release. This will be the build release command which is going to run for us. Okay, so we'll just create same thing for same job for running our unit test cases. Again, we'll just create a template test. We'll specify the stage in which this is going to run. We are going to specify a branch in which this runs. This will be brought into this one in test unit cases, and we have specified the script. So we have already done the 2 jobs, build and test. We have done those two jobs, and the last one will be for the packaging, the actual APK which we are going to generate. Right. So again, a package template. Over here, I'm just grabbing the version name of the APK which I'll be generating. Okay. And this is the actual job package release unsigned. Again, it's fetching the template. I've specified the staging. I've specified the environment. This is the environment on which I want to release this. This is the branch. This is the script which is going to run after the build is successful. I've specified the dependencies on that after on which previous job does this depend. This depends on the successful build of the build underscore release. I've specified again the artifactory. I've specified the path. So these are all the jobs which we have written over here. These are all the jobs which we are going to read for this demo. I'm sorry.
Just unlock it.
Slowly it will take time to load. Okay, anyways, we have written everything which we wanted to write over here, so we might not be able to see. Let's just commit it as of now and push it. Okay, let's just do a git add. Right, so let's just push it, and you will see that I've written the right content. The build will start running. Right, see, my build has now started running. As soon as I push the right content and right syntax, my build now starts running. If I just click on this running syntax, you'll see the three jobs which I have mentioned over there: build, and right. These are three jobs: build, release, test unit, package release. All these three are going to run. I can check the logs while these commands are running. So this is build, release running. So these are all the commands. You can see that it's fetching the JDK. As of now, it's checking out as master. Now it's fetching SDK tools for us. All of these commands are going to run. So this is how simple it can be for us to actually automate our APK generation, our unit test generations. Okay, I'll just show you, since this is going to run as of now. I've already had a previous project on which this successfully ran. I'll show you that project and what was kind of like the output of that project. So let's see, go with this pipeline. So this one was fast. So they ran successfully, build ran successfully, test ran successfully on those jobs. Okay, so I think it's been more than 4 hours, so I can't download the artifact of the build. But since I've specified a week or so for this staging artifact, you can see the path which we had specified for our APK generation. We can download our APK from this right from this icon. So now our APK is generated. I've downloaded artifact source zip. This is what is named. So that's how simple that was. If you have any questions in that GitLab CI YAML file, please let me know. Any syntax which you didn't get or anything like that, I'll open it up again so that we are missing out.
All of them run parallel, or they are like sequential? Like if one fails, then other will not start.
Actually, it is up to us. We can define if the other one is going to run or not going to run if the previous one fails. We can define the dependency if we want to. If we want that our unit test should run anyways, even if our build failed. Yes, that is configurable. And as you would have seen it, every time a build is going to run, suppose a build or test or packaging job, I am downloading SDKs again and again. So we can skip that step as well. We can specify as cache directory that these are caches which we can maintain and they shouldn't be downloaded again. So we can do that bar as well. So this is what we just need to do to actually automate all this process. If you have anything, any doubt in related to this, please let me know.
Can you please scroll up? What is this SDK tools and the particular serial number which you provided? Line number 4 or 3, I guess.
Just so usually SDK tools you specify 27 version or 28. As of now, I couldn't find out a way to actually specify the number and download those tools. That's why I've gone to the website and find out that they would have different releases and have taken that number from there and specified this one.
And regarding those build templates which you specified,
Right.
let's say I have certain parameters which are common and certain items which I want to be overwritten.
Right.
So what would happen if I include that template? So let's say if I have, let's say I say that the file stays for 4 hours in template, but when I'm including it, I say that it should stay for, let's say, a day. So will that parameter be overwritten from the build template, or what? How will it go?
It will be overwritten. Okay. So the one which you specified in template won't be your local one, would be given higher priority.
Okay. And the others will get merged. Like
Yeah, so all of this gets combined. So basically what it does that it combines the hash code of that template into yours.
Can I run multiple stages parallelly? Let's
Can
say
you run
if these are not dependent at all. So let's say I'm building. I know that my test depends on building, right? So let's say there is something else which I want to run simultaneously. Can that happen?
Yes, that can be done. So basically that would have been a little advanced for my demo. So
Okay.
there's
Yeah,
something called
okay.
groups
Okay.
over here in GitLab which they provide you, where you can specify the parallel branches which you want to run, parallel rows which you want to run. So that can be done as well. So that's it. Thank you.